So thank you and welcome. So I'm going to talk about Ruby and Postgres and how the two can fit together in a project.
Louder? Or
Is it on? No, it's not on. Is it on? Yeah. All right, so thank you. So some words about me. So I'm Franck. As he said, I'm French. I moved to the Bay Area a month ago for a new job. My Japanese is embarrassing. I just can't understand like anything unless words that are used in judo and jiu-jitsu because I'm brown belt. I'm a senior engineer, full stack engineer at Omada Health, and we are helping people at risk for chronic disease by enrolling them into a 16-week program designed to change their behavior. So I'd like to thank them for bringing me here. Japan is amazing. It's the first time I'm so far east. I'm discovering lots of things, and it's kind of easy to live here, I think. Plans like this are so easy. So yeah, it's so easy to get right to anywhere. The food is amazing, and that's true. We had some nice sushi in the Bay Area. We don't have nice sushi in France, and it's awesome. And you can even like learn new feelings. # possibly TMI. My hotel room is nice. No, that's yeah. They told me it was a nice room, so I guess I have TV, so everything's fine. A quick word, so I love my family, I love my children, and my son is 7-year-old, and he's just completed the Hour of Code kind of contest, and so he's got a certificate. So Warren, if you see me, it's Daddy, so congratulations. So I'm going to talk about SQL, of course, about Ruby, of course, and just enough of Postgres API so that you can understand how you can integrate foreign languages and foreign technologies into Postgres. I've been using Postgres as a user since 2009. And Postgres, so how many, quick poll, how many of you use Postgres? Yeah, almost everybody, so that's cool. So that's a fully featured relational database. It's got a clean, yet large code base, very large, and a super active and friendly community. So if you want to contribute, it's going to be so easy to get going. So when would you like to use raw SQL instead of using active record or some other gems that are going to abstract SQL from you? It's basically when you need for speed, because we say that Ruby is slow, but when you have to crunch billions of records, it's going to be easier to go with a raw SQL. And also, you would like to use raw SQL when maintaining the business logic in Ruby isn't the best. So if you have all your data in the database and you have the Ruby client getting the data in the database, and for some reason you want to optimize and use Go or Rust or any other language, and you don't want to replicate the business logic in the other technology, in the other language, maybe you need to push that to the database and using the database instead of real application code. I also love Ruby. I've been using it since 2006, and I've been a Rails programmer since 2009. I love Ruby because I think it's efficient. It's easy to design and use DSLs. So the most famous DSLs have a broad, there's a broad range of DSLs from ETLs, so extract, transform, and load. So the Kiba gem is an example, a nice example of that. And you can define a lot of other DSL, like the workflows, state machines, generating fake data, use Ruby on Rails, and so many other gems. So for instance, generating fake data, you can do that in Ruby and you can do that in SQL. In Ruby, it would just look like that. You have a factory, and you would just define the factory and then create very easily your new record. And using SQL, it's a bit different. You would need to generate the data using a custom script, so a PL SQL script, or an external tool, so you materialize the data in the database. Or you can do that on the fly using functions, but still using PL SQL. You could also want to de-identify or anonymize sensitive data. So by sensitive data, I mean PCI data or protected health information, anything that is sensitive. There's almost the same kind of, that's almost the same topic. You can do that ahead of time in Ruby, so you duplicate the content that is safe in another table, so you also materialize the safe data in another table, or like just in time. So you get the data out of the database, you process it, but it's too late. The data that is sensitive is already in memory. Or you can use views using SQL. So it's a combination of a view and functions that you call inside of the view. Cherry on the cake, you can also materialize the data. So it's going to be easier to get the data out of the table, but you will need to find a way of refreshing the data. And you can generate lots of crazy things in SQL. So yes, that's a Mandelbrot set. So if you have a mission-critical application that needs a Mandelbrot set, yeah, you should ask somebody. Some love SQL a bit too much, maybe. So I was using all those gems written in Ruby, and I was like, in January, I wish I could just inject those gems into Postgres and use them as they are. So I remembered that I could just use Ruby as a procedural language. So I went on Postgres documentation and found the link. So I said to myself, cool, something exists. Oh, RAA doesn't exist anymore, and it's from 2013. So I said, all right, let's go to Rubygems. And I saw these gems, it's not even the right name. So I said to myself, maybe I should go to GitHub. And I went to GitHub and boom, I had the project. And then I took a deeper look and 2010, that's probably not gonna work. It's going to be probably 1.8, so it's not okay. So I did a quick search about every kind of mechanism that exists into Postgres to integrate foreign technologies. So I'm gonna talk about 3 of them. So one is the first one is a procedural language handler. So like the project I showed before. You have index access methods. So it's a way of creating custom indices into Postgres, and foreign data wrappers. So how can we build a procedural language? Because the one I showed you is probably 1.8, and I wanted to have something more recent. So it's actually quite easy. You just need to define one method. It's going to be called a handler. Some data is going to be passed to that handler, and you can just integrate anything. It's written in C, so you can really integrate any kind of C program into it. So for those of you who don't know the word datum, so that's the Latin word for the singular version of data. Yeah. Then you just create a function. Given when you pass that handler to that function, you create a language out of that handler, and at the end, you're going to be able to just create a SQL function that is going to use Ruby under the hood. So that's how you do it. So I started working a bit on what I'm calling PLM Ruby. So it's a very buggy but early version of what I'm probably going to release next year, and it's actually working. So when you select anything out of this function, it's going to run Ruby, the Ruby that is contained in between the 2 sets of $signs. Another way of integrating a foreign technology into Postgres is index access methods. So PostgreSQL, it's on dog food when it comes to defining and using indices. And if you've ever created an index, maybe you've never used the using keyword inside of the create index statement. By default, it's going to be B-tree, but if you want to use a full text search or anything that is not traditional, you might have to define to provide, the correct index type. So for instance, gist, gin, or any other kind of index. So an index in Postgres is just an external data storage that is going to use, that Postgres is going to use to find your data back once it's inserted. So the index access method, the IIM API, is quite big, so it's not even the whole set of callback routines that you could use, but each one of them is going to be called when the PostgreSQL is going to try to get your data back from what it knows of the index. So creating a custom index using a custom index type is basically that. You create the index, you use the using statement, keyword inside of it, and you provide it the index type. So here it's just a simple index type that is called MRB random, which because it's built also with EmRuby. You pass some additional option, and when you select data out of this table using a custom operator and a custom function, you can see that Postgres will use your index and it's going to use your own code. One interesting example is ZomboDB. So ZomboDB is also an index access method, but it's using something else. It's using Elasticsearch. So if you want to have full text search with Postgres, it's possible, but Elasticsearch does a much better job. Maybe I shouldn't do that, but it doesn't say that. It does a better job and aggregates too. So you basically do the same thing I've done with the custom EmRuby index. You just state that you use a ZomboDB index type, and then when you can just use a traditional SQL statement. You use the index by using the operator here, so the arrow-shaped operator and the ZDB function, and it's actually going to go to Elasticsearch and get the data out of Elasticsearch using the keyword sports box and that type of stuff. I haven't seen any usage of EmRuby in the wild for IAMs, but I would love to know if there are examples. The last part is foreign data wrapper. So what's a foreign data wrapper? That's still a C program, but you can actually use Postgres to access data that is not inside of Postgres. So for instance, you can check your emails, do HTTP calls, read something on the file system, or maybe put some data in a NoSQL store. So how does it work? So in Postgres, you have the local tables that are at the bottom of this diagram, and you have foreign tables. And foreign tables are going to leverage the foreign data wrappers that are responsible for getting the data out of, for instance, here, MySQL or a CSV file. And what is cool is that you can even join the data sets from the foreign tables and local tables. And you can also push some predicates. So you can do anything. It supports reads for the selects, writes for inserts. The predicate pushdowns is about getting the workloads and pushing it to the foreign data store. It's actually better to do that because if you were to get the data out of the foreign data storage and match the predicate in memory inside of Postgres, it's going to be slow. So when you use a predicate pushdown. So for instance, with ZomboDB, you just push the workloads inside of Elasticsearch if you wanted to. And you have also routines for supporting explains and explains analyze. So it's a part of foreign data wrappers that are quite hard to master because you need to understand how the cost execution is built and how you can provide Postgres nice information so that the query optimizer know what it's talking about. There are lots of existing foreign data wrappers. So there's even one for Postgres, but any kind of mainstream database has a foreign data wrapper. You can find also foreign data wrappers for NoSQL technologies, for files, so from the flat files to JSON, and many more. And even MongoDB has a nice foreign data wrapper. So what is the minimal architecture for a foreign data wrapper? So basically, we need to understand the callback routine lifecycle. So every time you select something out of a foreign table, all those methods, all those functions, C functions, are going to be called. The one we can see at the top are about collecting data about the context execution of the query. And the body of all that is the iterate foreign scan. You can see here that it's going to loop. So every time you read a record out of your foreign data storage, this method is going to be called. And to end the loop, you need to return something like null, like the equivalent of null. So that Postgres knows that it needs to call end foreign scan. So I said to myself, we need a general purpose foreign data wrapper that supports Ruby, because there is one that was leveraging Python, but as I have all my code written in Ruby, I didn't want it to have another language inside of my database. That was not the plan. And it appeared to be harder than I thought. So embedding Ruby is actually quite easy. You call Ruby init, you have other magic stuff. You load everything in memory, your source code, and then you can just eval what's inside of, you can just eval the source code inside of the VM. And the result will be directly available for you. So if we go back to this life cycle, we can spin up a VM anywhere between get foreign real size and begin foreign scan. Then we need to iterate over something, and this something we will see later on what it means. And during the end foreign scan, we can shut down the VM. That's something we could do. So the basic structure of a basic data producer is like this. I haven't found anything else that was more efficient for me. It's just a standard class where you can pass extra information. And you can call the each method in the iterate foreign scan C function. So every time you call that method, it's going to iterate, call each, and enum next is going to loop. We can see at the end that I need to use self, and it's because when you define a function, when you define a method, in a class, it's going to return the name of the method symbolized. When you define a class, it's going to return not the name of the class symbolized, but it's going to return the latest statement contained into that class. So here it would just return each. That's not what we want. So I'm just returning self. So it's going to be the constant, the producer constant, and my Ruby program will use that by default. So I've built this foreign data wrapper. I've called it Holycorn, and it's pretty easy to install. You create an extension like you would do for HStore or any kind of other extension in Postgres. You then create a server. You create a foreign table that targets this server. And then you can just select data out of your Ruby code, which is pretty nice. So every time you would select star from a holy table, it will be another data set. So I was pretty thrilled about it, and I had to tell the world, like my friends at Heroku, and Terence Lee suggested me that EmRuby would be probably better fitted for that job instead of MRI. And the reason he gave me is that the idea would be that it's more safe for PG, and I had no idea what it was talking about. But I had some insights about why it was hard. Embedding CRuby is a bit challenging. Packaging gems is kind of a challenge, and parallel execution of the CRuby-powered functions had serious impacts on PG, and I had PG segfaulting for quite a while. So I had to give up. I had to give up also because I was using a multi-process type of architecture where I was forking inside of PG, which was not good. I also discovered that you can only have one VM per process compared to EmRuby. The MVM here is a multi-VM. I'm not even sure that's going to land into Ruby 3 or 4. I saw some guys mentioning that it was in somewhere in Ruby 2, I think. It was considered, but then it was not considered anymore. So I would like to know what's going to happen for MVM. And also, there's only one chance to put a VM per process, which means that if you call Ruby init twice, some things are going to fail. So it's maybe fixed, I don't know, but as far as 2.3, I think, you had only one chance to put a VMProcess. That's why I had to fork before starting Ruby. On the other hand, Embedding EmRuby was super kawaii. The VM starts very fast, and most of the Ruby language, the C Ruby language, I would say, has been implemented, or at least what you're gonna really use. So I didn't need it anymore, the multi-process and multi-threaded approach I implemented at the beginning. And it's easy to set up, so it's like just a dependency you add into your project, and you will be able to spin up new VMs quite easily. On the downside, there are a small amount of gems, so I had to rewrite most of the stuff I was using. But it's getting there. Lots of people are contributing to EmRuby and its ecosystem, so I think that I'm probably going to end up using only EmRuby in the future. So embedding EmRuby is quite simple. You just open a new VM using mruby open. You then need to parse. You can parse a string, so it's gonna return a state. You generate the code, you run it, and it's done. Nothing else. So I've released Holycorn at the beginning of the year. I think it was in May. So it works. It uses EmRuby, and you can find it on GitHub. It's LGPL v3 licensed because I didn't know what to do with the project, so I put a quite restrictive license. And there's a Redis foreign data wrapper that is given for free into that project. If you just want to know about the Redis foreign data wrapper, it's pretty simple. If you put any data into Redis, you will be able to access it using the foreign data wrapper. It is that easy. So we've seen the free ways of integrating foreign technologies into Postgres, the procedural language handlers, index access methods, and foreign data wrappers. They are all very nice, and I wish I could see more use of them and more use of EmRuby in PostgreSQL. So thank you very much.
「時間がだいぶありますので、質問を受け付ける時間」はい。
Thank you for this talk. It is very exciting. So I have wrote sort of hack using PostgreSQL and PL Python. And in that case, what I wanted to do is pushing down some conditions to a foreign data. I mean, if the SQL includes where key equals something, I want to scan only that row, other than scanning everything every time. So how does EmRuby how does this product handle those kind of conditions?
So the question is about handling predicate pushdowns into the foreign data wrappers, and how Holycorn is handling them. So as of now, what's been open source does not support predicate pushdown, but that's something I've been working on. So in the future, and I'm not sure it's going to be still open source as in with MIT or something, but it's going to be released at some point. Yes.
Thank you.
Thank you.
ここにいらっしゃいますでしょうか。
So how about performance? Do you have some benchmark results?
So will it scale? So the question is about performance. I did not run any benchmark right now. It's actually slower than a real table, but it's up to you or me to make it faster.
Right.
Yeah. Yeah.
Okay. Thank you.
But it's slower, definitely.
Yeah.
では今日ありがとうございました。
ありがとう。